Tyler Smith. I am the lead game developer and game developer evangelist at AppMobi. We specialize in porting one code base of HTML or HTML5 to multiple platforms through our build system, and we also have an integrated development environment for free to use for developers. This specific talk is going to be discussing a lot about creating cross-platform games with one HTML5 code base. Everyone knows HTML5 is a buzzword, and we all know it's awesome. But one of the main things is that it's very versatile, and the fact that when you run it on one device that has a browser or something to parse HTML, it can run on anything that can parse HTML. So this is a talk that's really going to go over the process that you should think before you create your HTML5 game, the different ideas that you should really have in your mind as you decide what game engine to use. And I'm going to use a lot of stuff from a game that I was the lead game developer on called Boomtown, which was a game that was created with one HTML5 code base, and we deployed it to 7 platforms, all using the same code base. So I'm going to be using a lot of things that I learned from that development process. Hopefully you guys can get something from it so that it's not as rough and you don't have as many catches that we did in our development. Real quick overview. First, we're going to decide what game engine to use. That's huge. I'm going to assume that you already have your game idea, what do you want it to be, either a puzzle game or a side scroller, and we're just going to go into the kind of thought process before you start developing and coding. Deciding the game engine is huge. I'm going to go through a bunch of different reasons why, but that is a really big one. Optimizing mobile performance. I'm sure everyone here has heard Mark Zuckerberg's comment about HTML5 and its performance on mobile. Regardless if you heard the sentence before and after that, that still was a big blow to HTML5. I'm going to show you a bunch of different coding techniques that you can use to actually get like 10 to 15 frames per second up just by doing really cool different things with software rendering and GPU rendering. What to look for before you decide develop for a platform. Wanting to do Android and iOS is great, but there's a lot of things you have to consider before you do it, and especially they'll influence what game engine you get, they'll influence how you develop your game and the touch controls and everything like that. I'll go in depth on that. Browsers versus hybrid app deployment. Because it's HTML5, you could just run it in the mobile browser on all of these devices. There's pros and cons to both. I'll go through that. Try to be as objective as I can. My company does do hybrid app development, so I might be a little bit more swaying towards that. But I'll try to show you the different things you should look for while developing your game, decide which way you want to deploy. Accelerating your HTML5 game to look native. There's a bunch of third-party stopgaps right now that take your game that might be running at 5 frames per second and get you up to 25 frames per second. I'm going to go talk a little bit about that, the development process, and if it's going to be right for your game. Packaging and deploying your game. Again, if you're doing a hybrid native deployment, there's a bunch of different ways that you can do it, a bunch of different build systems right now, and I'll go through all the different techniques you can do that with. So first, game engines. How do you decide? First, there's a giant list of games here that I just exited out, so I'll reopen that window. On GitHub, the presentation will be up for everyone to get later, but you can see that there's tons of HTML5 game engines right now. So your choices are pretty widened, so there's a couple things you want to keep in mind and look for as you are picking your game engine. First thing you need to know is, does it support the needed functions? Again, you should have your game idea. So is your game going to need collision detection, or is it a top-down puzzle game and you don't need collision detection? Are you going to need a level creator? Do you want something to create your level, or are you fine with writing in a canvas element all the different entities and where they're going to be placed? Are you going to need a sprite animator? Do you want to make your own? Are you going to do some weird things with your game that you want to change the sprite animation? So, and multiplayer is a huge one. Does it have socket.io, Node.js input? Are you going for multiplayer? Are you not? These are all big deciding factors on what game engine you get. And a lot of people, again, like to either make their own sprite animators or make sure the game engine does it. I personally like the game engine to do all the heavy lifting, so all I have to think about is tying into it and making my game. But a lot of people like to dig in, so it's really up against your personal preference. One of the biggest things I think for a game engine and deciding which one you want to use is it maintained? I mean, you saw that giant list of GitHub of all the different HTML5 game engines. A lot of people make HTML5 game engines and they go on to different projects and don't maintain it anymore. And the last thing you want is a game that you have half completed and where the person who made the game engine doesn't work on it anymore and it breaks. And then you have a half completed game based on a platform that doesn't work anymore and there's no one to help you with. So That's one thing to look for. Forums are always great. Is there a community based around that engine? Typically, a bigger community means it's going to have a lot more long-lasting power. I know Construct 2 has a great community. Impact.js has a great community. And I think those are two of the big ones that are going to stay. But there's something to look for is how big is there going to be support, not just from the person who created it, but from other people using it as well. Debugging tools, that's kind of like a cherry on top. I know Impact.js has a great debugging tool. It tells you a bunch of things, like it shows you the collision boxes, shows you the different velocities and how fast they're going, shows you the frame rate. It shows you a bunch of performance layout and peaks when it gets too high, when there's too many entities, so you can see where the problems that you're having in the game. Again, that's a cherry on top. It's not something that you might want to base your whole decision of your game engine on, but that is something, if you do like to have a really well-performing game and to get all the knowledge of what's happening in there, that's something to look for. Cost, I put it on here, but at this point, most HTML5 game engines are free, and if they're not free, they're about under $100, $100 or less. So that might be a factor if you're an indie game developer on the side and you just can't afford it. So definitely look in to see if it's cost or not, but typically it's going to be pretty cheap, and you might want to just bite the bullet and pay the amount of money if you think it's a good game engine for you. Personally, I think does it run well on mobile is one of the biggest things. There's a lot of great game engines out there, HTML5 game engines, but if they're 64 megs big, it's going to be problematic on mobile, especially if you do it through the browser. The browser's going to have to download all those 64 megs before anything happens for the user. So the user's going to have a horrible experience. It's not going to run well on mobile, and you just based your whole game on a framework that's not going to work for you. So if you're trying to get, I'm assuming that you're trying to get to all platforms, does it work well on mobile is one of the big key items. Does the game engine allow pre-rendering? The next slide, I'll talk a little bit more what pre-rendering is. Typically, that's another mobile performance issue. It's a way to make repeating background images render a lot faster, and I'll get into that next slide. How well does it scale on different devices? Again, since this is one code base on multiple platforms, you have to plan ahead for desktop, for iOS, on Android, Kindle Fire, all the different screen resolutions. So if a game engine has a problem with scaling to different screen resolutions, you're going to have a problem with that game engine to get it to different devices. So that's something to look for. Typically, you can find that if they do have a forums, or just doing a little bit of research, putting it on a device, seeing how well it does on Android and iOS. Does it have built-in device detection? That's kind of another cherry on top. There's a lot of third-party APIs you can use to do that. But I know Impact.js has a way that you can get into the iPhone. You can sense if it's an iPhone, an iPad, and then rendering differently that way. It's also with Android. So that's just something to think about. Does it support touch inputs? That is a pretty big one. Again, for mobile, if you're trying to get there, if it's not mobile ready, it's probably going to be problematic when you try to get it on mobile. And touch inputs, you can either work around it. Some have on mouse down in detection such as that, but it might not be 100% native feeling to the user since it's still kind of a hack around. So you really want to make sure that it's ready for mobile and it supports touch inputs. And how big is the engine file size? Again, if it's 64 megs, you're going to have a big problem trying to do it through the browser, or even on a hybrid app, it's still going to have to render it to the web view. All right, so this is a pre-rendering background. This is a demo game from Impact.js game engine. And I liked it because it was a really easy way to show what pre-rendering really is. Basically, instead of drawing a pixel all the way across the whole background every time you have a draw call, pre-rendering draws a separate canvas element, and then it saves that as a new image on the HTML5 context. And then for software rendering, the biggest problem for performance on mobile, the biggest problem is software rendering. So instead of doing 1,000 software rendering calls, you only do about 9 or 10. So that really helps performance. That'll take you anywhere from 2 frames per second to 20 frames per second if your game is really intensive on the background. You do typically need a repeating background to get that performance bump, but typically if there's a blue sky, if there's something extra that you can do to help pre-render, that will help your performance on mobile a lot. And that's an example of when it's being pre-rendered. You can see it's a repeating pattern to show that it is a pattern that's repeating, but if it's blue or something like that, unbeknownst to the user, it will look really, really smooth, and it will actually render a lot faster for you guys. Manage draw calls. I had the unfortunate task of making an HTML5 game work on a Nook color, which was not fun, as Nook color I think is running 1.9. At least it was at the time. So we had a game, Jelly Blocks. It used to be a popular web game. I'm not sure if anyone knows what Jelly Blocks is. It's sort of like Bejeweled. If you get 3 next to each other, they pop and the whole thing comes down. And we were having extreme problems with latency and stacking of touch events. So if the user would click here and drag it all the way to here, then the element would move. It'd be about a 2-second delay because we're trying to do HTML5 on Android 1.9. So we had no choice. We had to make it work. So to get around that, we realized every time we do a draw call, we're drawing everything. We're drawing the key, we're drawing the X, the sound, we're drawing the whole screenshot. When you click down, we know that you're clicking this element, and the only thing that really needs to be animated is a vertical and a horizontal axis. So we actually went into the game engine and we tweaked it a little bit to not do any draw calls or any updates except for that row and that column. And we saw about a 15 frames per second increase. It was still a little laggy when you clicked here to here, but instead of taking 2 seconds, it was about 0.2 seconds, somewhere around there, to the point where it looked a little sluggish to the user, but it was still a usability, and the user didn't understand that it was HTML5 and it wasn't native. So that is something that you should really look at if you're having a lot of problems with performance on mobile. Is there a way that you can slow down draw calls? Like I said, software rendering is the biggest inhibitor of performance on mobile. So the less you can draw with software to the screen, the better. So that's something to look for if you are having mobile performance problems. We also had, for Boomtown, we were told that it has to be 15 megs. And when we were completely done the game, we had everything finished, it was 26. So we said crap, and we went back to the drawing board and we said, okay, so how can we make this giant thing smaller? The reason why we wanted 15 megs, one, it can be downloaded over not Wi-Fi on an iPhone. Anything over 15 megs at the time, I think it had to be downloaded over Wi-Fi. I think that's since been pushed up to 40 megs. I'm not 100% sure. And the second one, again, the bigger your bundle is, the bigger HTML5 game is, the longer it's going to take to load. And that load time was about 4 seconds for us, and that was too much. So we needed to slim it down. We needed to hit 15 megs. So the first thing we did is we had a 4-minute MP3 looping background track. So we took that out. That was a huge. It was about 6 megs we took out, and then we dynamically cached it based on the device, because if you are developing cross-platform, we developed for the Mozilla App Store, and that does not support MP3s. So the way that we dynamically cached it on device, I have some pseudocode. This doesn't really mean anything, but if it's mobile, then at the time, all mobile, it's until boot to Gecko, which I'm not 100% sure if that will support MP3 format, but pretty much all mobile support MP3 format, and then if not, find out the browser name and load up an OOG file, and then if not, we load up an MP3. So there's a way, since your base has to be able to be deployed on all platforms the same exact way, there's going to be a lot of if-else statements based on what platform you're on, and this is just an example of how you would dynamically load a sound file for the background. The other thing we did is we used JPEGs instead of PNGs, and our graphics department hated us because we had this awesome looking, cool, the edges are burnt, it's really awesome. And then we said, no, it has to be boxes. So that it did make them mad, other than fights with your graphics department. So we took this is cool burnt edges, and you see the cool fades and everything, and I have to agree, it looks better, but it still gets the job done, and as an engineer, I think that's all that matters. We saved a lot of space too. We went from 232 kilobytes on this image to 21.7. So when we rearranged our whole UI, still leaving some PNGs in there, but all the ones that are non-important, all the ones that are UI that could be dumbed down a little bit, if you get there, then you can save a lot of space and a lot of megs. I think we saved about 10 megs alone by changing everything from PNGs, half the UI from PNGs to JPEGs. Yeah. This slide's in here just as a sort of a reminder. It's not really that important, but if your game needs native functions, remember that from the beginning. It helps to let you know what game engine you need and how you're going to deploy. Native functions would be accelerometer if you have a Plinko type game and you want to be able to accelerometer, or a racing game you want the car to be based off of the movement of the device. Geolocation, if you have some sort of Mafia Wars thing that you want someone to go to a certain location to get a cache of money or something along those lines. That's something to think about again when you're developing your game. Camera, if this may be some sort of augmented reality aspect to your game, you need to know if you're going to need that native function, because that will determine what you use to deploy it. Contacts, not 100% sure how you use them. Maybe you just take them all and put them on a database somewhere. I don't really know. But if you want to use contacts, it's something to think about. And then research-supported platforms. This is the biggest thing that we did before we made our game. We decided we were going to research everything before we did it, and we got a bunch of just blank divs and a bunch of other divs on top of it, positioning them certain ways to try to see if we can't get the screen to fit on all the different devices, because again, the aspect ratios are weird. But the first thing you need to think about is where the control is going to be, placement on screen. If you're on a desktop, you're going to have a mouse and a keyboard. That's great. So you have X, Y, maybe WASD to move him. But then when you move it over to a touch device, you have to think, how is that going to play out? Where are you going to position it on the screen? You have to make sure that when you do position it on the screen, it's dynamic, absolute position, bottom 0. Because if you position it 655 pixels from the top, and relative, when you have a smaller screen size, you've got to cut off the touch input, and your users aren't going to be able to play your game. So controls are a really big thing to think about. How are your controls in the game idea you have going to translate between each device and each usability to the point where I can play on Facebook and I can play on my iOS device and say, yeah, I just played the same game. You don't want it to be intrusive and completely different. You want to try to keep the same feeling, because typically if users like your game, we've seen a lot of people play Boomtown on a bunch of multiple devices, which we encourage. So that's something to look at. And will you need multi-touch is another thing. Right now, Android WebView doesn't support multi-touch. So if you do it through the browser and you have a jump and run game, you're going to have a problem. So you have to keep these things in mind. What platform am I going for? Can you develop for Android if you have a multi-touch game? If not, you're going to have to go hybrid app deployment or something like that. So definitely something to think about. And HTML5 support, like when we developed for the Nook, that was running Android 1.9. We knew the support was bad, but we had to do it. So a thing that you have to do, or that you can do, is look at the canvas tag. That's the main thing. Most HTML5 games use the canvas tag relentlessly, because that's the coolest thing from HTML5. It's pretty much the golden egg. So does it support it? That's number one. Otherwise, you're not going to have a good time on that platform. Audio tag. I'm assuming everyone here understands HTML5 audio and the problems that come with it. I don't have to go into that. You just get one handshake. It's bad. That's pretty much how you can do it. It's bad. But does it support it? That's still good to know. If you're trying to go through the browser, you still need to know, does it support HTML5 audio tag? Audio is extremely immersive when it comes to gaming. If you don't have a gunshot when you shoot a gun, it loses like half of the coolness of it. So will it support audio? And just typical HTML5 performance. Run a couple performance tests on that device to see if it's willing to do what you want that game engine to do and what you want your game to do. Just through maybe spawning a bunch of entities on a screen at once and seeing what the performance is like. And this is the worst one, screen width and height. Thank you to all of the Android, or thanks to all of the Android devices and all of the new resolutions of the iPhone, there's a ton of different screen widths and heights. And then you have to factor in Facebook gaming, Chrome Store gaming, and just basic desktop on the web gaming. So there's a lot of differences between width and height on all those different devices, and you really need to research the platform before you go for it. I'll get into that right now, why. First thing that we've noticed is people who are developing HTML5 hybrid apps go for iOS first. It's just what they do, and then they make an Android version. That's just what people have been doing. So when it comes to a portrait game, it's not as bad, since you can see on the iPad, we have a 4:3 ratio. So when you have an iPhone, all you're going to really have is a couple pixels to play with. Maybe you put an ad in there. Maybe just put some bleeding background image so that no one can really tell. It looks like some ambiance on it. And when you get to Android, again, you're adding space. Adding space isn't too troublesome. That I would recommend, maybe because Android doesn't make too much money, put an add in that extra space. Just don't leave it black. Then people can tell that you left it black and it's supposed to be something there. Landscape is where it gets really awesome, because if you develop for an iPad, you're going to have almost a half of the screen on an Android device because its ratio is 7:4. So that is a huge, huge factor when it comes to developing HTML5 games that are cross-platform. Are you going to develop for Android and iOS with one single code base? Because there is a huge gap here. Even from the iPad to the iPhone, you can see this giant chunk of gaps. So that's something to think about before you develop, and it's definitely something you need to know on the platforms that you're developing for. What is their screen width and height ratio? The way that we tested this for Boomtown is, again, we took all those HTML5, or we took all of the divs, and we just put blank divs, and we knew the positioning of them, and we had a readout, and we said, okay, so if I put a floating 500 by 500x, where does it show up on this device? Where does it show up on this device? Okay, so we need to make it smaller, we need to float in the middle, and we went through a bunch of different processes, and this is what we ended up with. So at the top, you can see that's iPad. We got the cool cowboy hat, we got horns, we got a sunset. It's a really nice background, some ambiance. You got that whole barrel in there. See the cactuses, it's nice. It's a nice game, nice looking game. But when you get down to this Android, you can still see the whole game board. You still see leaderboards, music. Everything that you need to functionally play the game is still there. So we made sure that when it floats in the middle, on the smallest device screen ratio, it still works. And that was one of the big things. And you can see down here on the iPhone, it cuts off the cowboy hat a little bit of the tip of the bullhorn, but users don't typically notice that. When this is cut off halfway, they just assume that barrel is supposed to be cut off halfway because it's cut off halfway. So to them, that makes sense. When they play it on iPhone, they might go, oh, whatever. We never had any complaint of that, but that's one way to get around the device problem is float your game in the middle. Again, that's not going to work for everyone. Another way is if you have a top-down shooter or if you have a jump and run, you typically have a camera following the user. So if you make sure that that camera is dynamic in the way that it follows the main player, it's going to help you when you get it on these different devices instead of making it a stagnant 500 by 500 or any ratio. All right, so this is a hybrid app versus browser deployment for iOS specifically, and I had to cut them up because they're different. Again, I'm going to be, does everyone know what a hybrid app deployment is? I got 2 head nods and no no's, so I'm going to keep going. First thing, when you develop for iOS and you use a hybrid app, you're going to be making money. You can definitely sell it in the App Store when you compile it, or you can do in-app purchasing. Because it's a hybrid app, it's able to tap into that native API of purchasing, depending on how you deploy it. But when you're in a browser, you're not going to be able to do that. It's very intrusive to try to get someone to buy something through a browser that you might get some payments, but you're going to have a lot of friction through it. So it's something to think. If you're doing this for purely fun, you just want to have a browser game, that's one way. If you really want to make this a business, you might want to go into an app, a native app, but it's completely up to the developer. It's just the different things for them. The one thing that I really like, because when you make an HTML5 game, I want you to have the most native experience I can give you on every platform. I want you to not know I used HTML5, like a ninja. I'm an HTML5 ninja, you don't know I'm there. One of the things I really love about hybrid app deployment is you have native functionality through JavaScript APIs for Facebook and Twitter. And since everyone loves socializing their games, you can give them more coins, you can do anything about that. If you're on a browser and you hit Facebook, it's going to pop you to a new window. You're going to have to plug it in, you have to hit login, then you're going to have to allow, and then you have to go back, close the window out, and go into the other window. If you use a native API, you get a slot, you just pops over to Facebook, pops you back, and you're done. It just posted for you. So the usability of it and the native feel of it is a lot more stronger than when you do it through a browser. You get more screen space unless the user saves it to the device and then they get the full screen, which typically users don't do for browser games. You get more screen space when you go for a hybrid app, so that's another thing that I might think about. And locking orientation, it's a killer on a game engine when you go from portrait to landscape and then back to portrait. So if someone's playing on their bed and they accidentally flip it and flip it back in a browser game, there's no way to lock that down. So you're going to have a big problem with lag, and then it's going to be stacking, and the user interface is probably going to blow up, and then the person's going to delete the game and never go back. So that's one thing that's really important. If you require it to be in a certain orientation, which games typically do, you might think about hybrid deployment. There's no download time. Whenever you go through a browser and you download an HTML5 game, like I said, it has to download it all and then parse it to the screen. There's no download time when you're on iOS. You have to download it from the store, yes, but then all the files are locally on that device. When you bring it up, it just parses it right there. It doesn't have to pull it down from the web, and then you're ready to go. So there's a little bit of advantage to that. And then you have access to hardware acceleration. Again, I'll get into that a little bit later, but you can use third-party hardware accelerators that get your game from maybe 10 frames per second to 40 frames per second. And if you really want that native feel, that might be something you really need to do. And internet's not required. I beat up the browser a lot in this slideshow, so I want to do a couple things of why the browser is better than the hybrid. Number one, it has Nitro.js in iOS, so the browser, when you deploy through the browser in iOS, you're going to have a lot faster JavaScript parsing because you have the JavaScript core there in the Nitro.js. The other is, I try to remember these two. There's another one, but I just can't for the life of me remember it. Oh, yeah, and native sound. Again, HTML5 audio is horrible. When you do a hybrid app, it's horrible now. It will get better. But when you do a hybrid app, Native sound is definitely a plus. You can have polyphonic sounds, you can have multi-channel sounds, because you're going through OpenAL. And that has a lot more capability than through just a web view and audio tag. Now we can do Android. There's no multi-touch in the Android browser, which is a problem, again, if you're doing a jump and run. There's fragmented web views. HTC likes to go in and just make their web view a little bit cooler by doing things I have no idea, but it breaks stuff. And other Android companies do that. Hardware manufacturers like to make that Android version theirs. So when you're going to different Androids, you're going to have more fragmentation of the web view. You don't get away from that from hybrid apps, actually, because that still parses in the web view. It's just a problem that you have to think about when you're deploying to Android. How are you going to get around this fragmentation? And you're going to have to buy about 300 devices. Yeah, Android, these are all the same ones for the iOS when you deploy with a hybrid. Peak performance. I've been talking about these cool, edgy things that make your HTML5 run so fast. But what are they? Basically, there's 3 right now that I know of. If there's more and I didn't mention them, sorry. Number 1's Direct Canvas, which AppMobi makes, Cocoon.js, which Luday makes, and Ejecta, which is only Dominic from Impact made. And that is not cross-platform. That is iOS only. But I wanted to put it in here because he did some cool stuff. But the graph acceleration speeds up the HTML5 about 2 to 10 times. The way it does this is instead of parsing it through software rendering, it starts doing it through hardware rendering, through the GPU. So it's actually a native view with a web view on top of it. Well, I guess from you, it's a native view with a web view on top of it. So you're actually seeing OpenGL, or you're hearing OpenAL, and it's parsing it way faster because it actually can use the whole computer to do it. It's not software, it's hardware. And then you get about 2 to 10 times more parsing speed faster. We have taken a game that was doing 5 frames per second, and we got up to 40 frames per second by using Direct Canvas. So it definitely is a giant performance gap, or a performance leap when you do this. For Direct Canvas and Cocoon.js, you get multi-touch support for Android. So not only are you getting this acceleration, you're also getting multi-touch support. So you can do that jump and run game on Android and iOS if you don't do it through the browser and you compile it and send it native. So that's another, it's misspelled touch. That's just how you spell touch on the East Coast. Yeah, it uses JavaScript core, OpenGL, and OpenAL to render. You still write it once and deploy everywhere. I put that asterisk because that is Direct Canvas. I believe Cocoon.js, when you compile with it, it'll work in both. So that's also Cocoon.js, not Ejecta. Again, that's only iOS. But so if you make your game with Direct Canvas and you deploy to iOS, you can also deploy it to Android in the same exact form it is, just using our build system. And then you can also deploy it to Facebook, Chrome Store, Mozilla Store without doing any of that. We compile it in the back end to make sure that it's not OpenGL anymore. It acts like HTML5, but you don't have to rewrite your code. It's the exact same code base. And that's what we did with Boomtown. Okay, and then how do you deploy HTML5 build systems? First, PhoneGap. I'm sure all of you know who PhoneGap is. Yes? Yes, okay. They have iOS support, Android support, BlackBerry, which for games, I don't think that would really do anything until 10 comes out or 10 came out. I haven't been able to play with it if it did. Palm, which is, you can develop for Palm. I'm not sure if any new devices are being made. And Windows Phone 7, which for games, again, I don't think Windows Phone 7 can do gaming too well. Windows Phone 8, I know, is working really well towards HTML5 gaming, but I'm not 100% sure about Windows Phone 7. AppMobi's build system, we have iOS support, Android, Amazon Store, the Kindle Fire Store, the Nook, Intel App Up, Mozilla App Store, Facebook, and the Chrome Store. So those are all native compiled for you in the cloud, send it back down to you, then you deploy it, and all you have to do is give us credentials before we make the build. Cocoon.js, that deploys to iOS and Android, again with that acceleration. And Ejecta, iOS only, but this came out about 2 days ago, and I really wanted to include it in my slide, my presentation, because he did something really cool. He got really high frames per second when even using things like 3JS, and I think he even showed a demo on Vimeo of him getting 60 frames per second while taking a 3D model and skewing it with touches, which I was really impressed about. It's really cool, and it does support more things than his own game engine, which is Impact.js. I just want to put up here because it is another accelerant that you can use to get your device in the App Store. And then Osmomium, which Ashley from Construct 2 told me about. It's really cool. You can actually deploy your HTML5 game as an exe and a DMG. I'm not a Mac guy. Is that the Mac store? Yeah, and a DMG into the native Mac store. So you can actually have an executable on your laptop that will pull up your HTML5 game and play it in a window. So I thought that was pretty neat. I should include that. And I don't know where I am on time, but that is all I have.